Okay, it's 8 a.m. Looks like they're not going to be doing an MC this time, so I'll just take and run with it. Everybody okay with that? Sure. All right, beautiful. Had a couple cups of coffee. I'm ready to go. So, this particular talk is a FujiNet State of the Union, more specifically, where we are at this point in time and what has happened in recent history with the project. Last year, it was a talk about how FujiNet had grown by leaps and bounds as more people have come on and code got folded in, and so we won't really go over that so much. So we're going to be taking and looking at more recent stuff. But I will say that over the last 5 years, FujiNet has become an extremely mature and multi-platform open source project with many people contributing. We'll also be going over the Apple II bring up that's basically reached production now, and we've got people taking and building them. We're also looking at other vendors to take and fill out the need for the Apple II community. We brought some Apple II units here to sell. They were sold out pretty much within an hour and a half, which is absolutely amazing. We'll also be talking about the Macintosh 68K bring up and some of the things that we had to do in order to make that part of it work, because it brought in some new architectural challenges that we had to solve and what we had to do to solve them. We'll also be talking about the TRS-80 Color Computer bring up that started at the beginning of this year and is proceeding along at an incredible pace. We're talking about a little bit about the FujiNet Game Lobby and also some of the things that have come along with it, because there are things here on the front of this page that I've added slides for things like the Atari 2600 bring up that just happened over the last couple of weeks, and the fact that the 2600 client has a 5-card stud client now. So FujiNet is indeed a very mature multi-platform project. We've been moving on to more platforms. And not only have we been moving on to more platforms, we have Apple II, Macintosh 68K, TRS-80 Color Computer that are coming up right now as we speak. We also have been bringing FujiNet PC, which is our PC-hosted version of the FujiNet, where we took the FujiNet firmware as it was, replaced all of the ESP32 calls with POSIX and Win32 calls so that it could run on any standard PC, Linux, or Mac machine. And we extended that from the Atari 8-bit, where we started, over onto the Apple II. And we want to take and be able to bring that to other emulators as well, such as TRS-80 Color Computer, and ostensibly any machine that we have a physical device for. Why do we want to do this, though? Well, the biggest reason is we want to be able to take and have software developers be able to take and use the emulators for each of these machines and to use the excellent debugging facilities in those emulators so that we can basically take and so that we can get software developed faster turnaround, and then it can be tested on real hardware. We also have more contributors that have come to the fold, such as Mark Fisher, who's in the front row here. He has been very instrumental in adding a great deal of discipline to our development process, adding in test-driven development. His talk yesterday was basically on the FujiNet library that we have been consolidating functionality down into, making everything a nice, consistent API, as well as creating an entire test framework so that we can take and have reproducible test cases for every bit of that API. We've also had help from Oliver Schmidt of the A2 RetroNet project, who makes devices like the A2 Pico, which is a software configurable Apple II card that can become all sorts of different things, including a soft SP card and other things like that. But he's been helping Mark with the integration of FujiNet and FujiNet PC to create the bridge. We wound up using a form of SLIP as the bridge between the two. And yes, anytime that you see kind of an asterisk in anything that I have up here on the bullet point here, these are potential places where you can help. And in point of fact, anybody can help with any of these things that I'm talking about here. Just this last week, Oliver Schmidt and Mark Fisher ported the web browser from the Kentucky project, and it's starting to work. There's still a lot of work to be done. It requires bleeding edge firmware for it to work, but we have the World Wide Web on our Atari and Apple II machines using the same consistent interface and using the protocol stack that's built into the FujiNet to do all of the heavy lifting so that we can not only display what we have here, but potentially be able to take and swizzle down images, be able to swizzle down things that traditionally have been very difficult to do on these retro computing platforms because we have all this processing power sitting inside of the FujiNet. We had a Polish developer come in this last week and add TCP transport support to the TNFS protocol that we use for file sharing. This is very good because traditionally TNFS was done over UDP. UDP is very simple, it's very straightforward, but it does have its issues, such as you have to deal with the fact that packets may come in out of sequence. You may have to deal with the fact that packets may drop. And on less reliable connections, say trying to have access a US server from all the way over in Poland, that can result in dropped packets, in slower transfers, etc. So they took it upon themselves to take the TNFS server code, which had functions built into it for doing TCP stuff. They were just stubbed out. They came in, they implemented them, tested them, gave us a pull request, and we pulled it in, and it works. So all we really have to do there, they made it, at least temporarily, so that if you put _TCP in front of the host name here, like you see in the host list, it will open up and use a TCP connection. And at least for them, it has improved their quality of life considerably. And over the last week, we've had to take and fix various problems in the version of Mongoose that's used for FujiNet PC. Mongoose is an HTTP library, and it's what's being used under the cover for the HTTP protocol adapter. And there were a lot of little things that we really needed to take and fix. In addition, there has been a flurry of work on the FujiNet library. The FujiNet library is Mark Fisher's pet project to basically take and build a consistent API for writing FujiNet applications in C, no matter the platform. So whereas in the past we've had to take and have boilerplate code for all of the various functions to open a connection, close a connection, read, write, get status, that sort of thing. He has abstracted that into a consistent API for programs that are written in C, and there's been a considerable amount of work to get this ready, along with the testing frameworks and everything, so that we make sure that everything works nice and consistent. And really, it's honestly a case of there are decades where nothing happens, and there are weeks where decades happen, and that's the case of this project right now at this particular point in time. It's absolutely amazing. The Apple II bring-up is now at a point where it is absolutely rock solid. We consider it pretty much production ready, and we've been making production hardware now for months. And not just for Apple II users, but for Apple III users as well. Oh, come on. Really? All right. Excuse me. That's fine. Here is a picture of an Apple III running a ported version of the ISS tracker, the International Space Station tracker. This is the application that we use as our Hello World because it demonstrates a whole bunch of wonderful concepts of being able to take and pull something off the internet, use the FujiNet to parse it, and then the computer can just basically query for the bits and pieces that it needs. And on the Apple III, you had the extra benefit of the sophisticated operating system and its device driver blocks so that we can take and add specific devices for the FujiNet. Robert Justice has been doing some incredible work there, making sure that all of that works as well on the Apple III for the 10 people that have an Apple III. So what's next for the Apple II? So this has already changed. This actually exists, so we can get rid of that now. FujiNet PC now exists for the Apple III, and now even if you don't have a FujiNet, you can take and get a copy of FujiNet PC. There's even a virtual machine that Ben Krein has been working on here that takes and combines the Atari and the Apple emulators with copies of FujiNet PC, all in a virtual machine appliance that you can take, download, and deploy on your desktop machine for quick development. So what's next for the Apple? Applications, applications, applications. Get more applications ported over. We port over the lobby. We port over the 5-card stud example games so that we can start, so that the Apple II people can take and join in, start doing multiplayer games. So the Macintosh 68K has been coming up at warp speed as well. The first development boards have been made. And okay, I originally did this on a totally different desktop here, so it's asking for a viewer that I no longer have. I switched from KDE to GNOME. Oops, just give me a moment. I have to find, yeah, there we go. If you want to see, this is the inside of a Mac Fuji board here. And for those of you who've seen FujiNets for other platforms, you'll notice something very interesting here. There are 2 microcontrollers sitting on this board. The first on top here is our venerable ESP32, which runs the majority of the FujiNet stack. But the Mac needed faster signaling at the floppy port than even the Apple II needed. So we decided to take and leverage the Raspberry Pi Pico, and more specifically the RP2040 microcontroller that's on the Raspberry Pi Pico, specifically because it can take and move bus signals. It can change bus signals and bus signal states very fast. It has 2 of what we call the programmable I/O macro blocks. They are very small nanoprocessors that run independent of the ARM core that's on this particular chip, and you can have them run little state machines that do things like react to bus signals and do so very quickly, and furthermore, do it under DMA so that these things can happen completely independent of the microcontroller here. There is a connection from the RP2040 to the ESP32 over UART. And that's how the communication between the 2 is done. And because these RP2040s are made in such a ridiculously high yield, the single cost for the RP2040 chips by themselves is 50 cents in singles. Seriously think about that. For those of you who have done FPGA or CPLD type designs to take and do logic glue for various hardware projects, this is a major game changer, because if you can do all of the bus arbitration and bus glue on a part that is potentially a fraction of the cost of a programmable logic device, then that means that's a win for everybody. And yeah, I'm wanting to see what future generations of this particular microcontroller will actually bring. But I'll end with the final thought on the RP2040. With every single bring up that we do, it gets us a vector onto 10 more systems that we can potentially go to. The example here is that what we learned with the RP2040 and what we're learning with the RP2040 is telling us that we can use it as a front end for bus-based machines, parallel bus-based machines. Think everything from an ISA slot to the cartridge slot on a video game console. It means we can go anywhere and do it at price effectively. So with the first development boards, we can currently take and use floppy or DCD images. And that basically means that we can boot up, and what comes up is essentially a, let's see. We have FujiNet booting up from the network onto a Mac, plugging into the floppy port, acting like a combination floppy port slash old-style HD20 DCD hard drive, dealing with images directly. And what's next up is the desk accessory for the Mac, so that we can take and do the same things that we're doing over here on the Atari version of config, but in the Mac context. And we're implementing it as a desk accessory, so it's just available at any time, no matter which version of Mac OS you happen to be running. And for those of us who are doing the Mac bring up, we have a variety of older Macs. We're concentrating on the older Macs that can't run a copy of Mac TCP, that don't have the muscle to be able to do SSL or TLS. So we're talking about Macs like the Mac Plus, the Mac 512K, or even the venerable Mac 128K. And I test for everything that we're doing here, such as the desk accessory, making sure that they can run on any version of system that these older Macs can run. I've even tested this on system 1.1. It works. So I'm making sure that it will work. So yes, if you've seen the configuration program before, it's exactly the same consistent interface that you've seen elsewhere. You take and you have host slots. You load files from those host slots. You drop them into the drive slots. And you have a secondary menu here where you have the other functions that config needs, such as setting up your Wi-Fi network or showing the current network configuration. So what's next? Next for the Mac, we're trying to figure out, okay, we've managed to make this thing properly simulate a disk drive and a hard drive over the floppy port. Now we need to figure out, how do we expose the FujiNet control devices and the network devices over using the IWM that's present in the Macs here, and working out the signaling so that the network device will work, so we can write a device driver so that networking will work, and so that printing can work. Because remember, the FujiNet has a built-in virtual printer too that can render all sorts of emulated printers and run them out to PDF for your modern printer. And again, these are all places where you can help out if you can. If we have any Mac hackers in the audience, please, we'd love to see your thoughts and insights on how we can make this better. So now that brings us to the TRS-80 Color Computer bring up. This one has been happening at light speed since the end of last year. It works on all of the color computers, the 1, 2, and the 3. The current version plugs into the cartridge slot and provides the HDB DOS-ROM, and we have a pigtail that goes back to the back for the serial port. We want to get rid of the pigtail. So the next phase there is to take and streamline and simplify that interface so that it can go directly over the bus. But even at this particular point in time, we can do disk and networking. This was an early breadboard that still had the cassette interface attached to it. You no longer have to bootstrap it. This has changed even from this particular point in time. But once you're inside, you have, once again, the same mechanisms that you've seen on other FujiNet platforms to be able to set up your network, to be able to, I'm wanting to move across here so I don't have to, okay. There we go. But you also have the same UI for entering in host information, for looking at files on remote servers. Again, but it's formatted for the TRS-80 Color Computer, which in this case has a very small screen of 32 characters by 16 lines. So we've had to take and split things up a bit. But all in all, no matter the platform that you choose, you get the same experience. Out of the box, you're able to take and load software directly from the internet or from local storage. You're able to have the virtual printer, and you're able to have the networking out of the box now too. Since this video was made, we've made some example applications, and you can see them at the table to do Mastodon posts, ISS tracker, etc. So the color computer is coming up very, very quickly. FujiNet on cartridge, which that has now come up, and let's see if this is the right picture here. Maybe? Can't tell. Oh, this is the inside of it here. What we wound up doing was embedding the ESP32 on the cartridge and having a ROM slot at the front of the cartridge for all of the versions of HDB-DOS that the Coco can actually run. And I said before, the final optimization is getting rid of that connector on the end there and doing everything directly over the bus. And again, as always, we need applications. We will write all sorts of demonstration applications so you can see how easy it is to write FujiNet applications. But we need more help. And perhaps the craziest thing that I have ever seen on this project here, I knew that we were going to get here at some point and start having support for game consoles. I did not think that it was going to be the Atari 2600 would be the one that came up first. Because if you think about it here, think about what the Atari 2600 is. It is the most bare bones, bare metal 6502 design you can possibly think of. You're talking about a single processor and an I/O chip that happens to have some memory sitting on it, 128 bytes worth, and you're having to take and bit bang the screen. But regardless of that, we've managed to take and port the PlusCart firmware all the way over to the RP2040. We built a test cartridge here so that we could test the work that we were doing. And we got to the point where we were able to take and boot and stream games over the internet. And in yeah, thanks. Yeah, it's insane. And now even, so at this point, when I wrote this particular slide, we hadn't seen 5-card stud yet. And all of a sudden, 2 weeks ago, we had somebody come into our Discord and say, oh, we've been working on a version of 5-card stud for the prototype board. It's working. We're going to take and demonstrate it on the Zero Page Homebrew podcast tomorrow. Wow. And they did. Over a 2-hour podcast, they took and they demonstrated it to thousands of people, and it was absolutely amazing, and none of us even knew it was happening. But that's kind of the nature of what we're doing here. So what we wound up with was essentially a version of 5-card stud. And if you come by If you come by the booth, you'll actually see it in action because he got it actually communicating with our servers directly and basically playing a game. So now we actually can say that we're doing cross-platform gaming between the Atari 8-bit, between the Atari 2600, and with the other versions of 5-card stud that are being worked on in C. We can attack the Apple II, the Commodore 64, the TRS-80 Color Computer, all the machines that we currently have bring-ups for. So for the first time in history, we have true cross-platform gameplay between all these different retro computers that is going to happen very quickly. And that brings us to the FujiNet Game Lobby. The question arises, once you start having all of these different game servers, games and game servers available, how do you get to them? You need to take and have some sort of, directory, some sort of way to actually get to these individual games. If you look right here in the Atari version of the configuration software, there's a button to go into the FujiNet Game Lobby. And what happens is it then takes and boots into a directory of games that you can play. It has a chat feature in the middle here, but you'll see that we have different rooms for 5-card stud with combinations of both human and bot players. You have the ability to take and chat between members. And once you've selected a game, it mounts the game, goes and streams it directly off of the network, and passes any session information to the game so that you can be ready to play immediately. And see right here, we jump right into a game where we're waiting for our next turn to go ahead and play through. Anyway, so all sorts of interesting possibilities here. Looks like I need to go back into org tree slide mode because I fell out. Give me just a moment. What happened? Okay, 1 second. Okay, get back to the slide where I was. And that basically means, too, that the lobby and 5-card stud are now stable for Atari systems. Now the challenge is to take and port the lobby to all of the other systems, Apple II, Commodore, Atari 2600, and so on. The lobby is written in C, and it is extremely cross-platform. So you can go through, and we can quickly adapt it for a whole stack of different systems very quickly, just by changing out the system-dependent portions very quickly. Here's the funny part, too. 5-card stud is also written in C. So that means that just by changing out the system-dependent portions of it, we can take and bring these things up quickly. The issue has been, for us, limited developer pool, so we're having to take and time slice our time, not just between doing these games and whatnot, but for also doing the bring-ups for all the other systems. And these are areas where if you can help, we would really enjoy the help. We could really use it. Oops. We're also working on a set of users guides for the FujiNet, starting with the Atari version here. And the whole thing here, this is a professional typeset book here that you can see. It looks like a full user's guide, which is basically split into 3 main parts. We have the user's guide, which is the owner's manual getting started. This is how you set it up. This is how you use the basic functions of the unit. And then we have a programmer's guide, which shows how to write FujiNet applications in a number of native programming languages, such as BASIC or Action on the Atari, writing applications in C, writing them in assembler if you wish. All of these things are catered to. And that's the whole point of that particular section, is to be a Rosetta Stone by taking the same examples, such as Mastodon and ISS, and showing how you write them in each individual language. And it looks like it wants, yeah, there we go. But you can see a lot of time and effort is going into making this look absolutely fantastic. And you can see right here in the programming guide, going through the sections. If you've seen my talk, if you've seen my classroom talks over the last couple of days, this is a sort of printed version of what I've been going over in those classes. How to take and open network connections, how to read from those connections, how to write to those connections, getting connection status, and so on, closing connections. And finally, for each individual language, like I said before, you have example programs. How to take and write a simple terminal emulator in about 20 lines of BASIC, explaining what each line does. And the same thing for Mastodon. This is about 12 lines of BASIC code that will literally take and open up, pull off on the web, grab a JSON document, parse that JSON document, query that JSON document for the bits and pieces of information that you need, and then displaying it. Very straightforward. And if you've been in my classes here, I've been touching on all of this. Finally, in the last part of that particular manual, there is a reference. And the reference guide primarily deals with individual commands that are present, such as on each of the operating system disks and how to use them. The NCD command, the NDIR command, and so on. I have been working slowly on this, and I'm hoping to have this at least done by the end of the year. And for those that want to see it, it's, again, like everything else that we have, it's up on GitHub in the FujiNet manuals repository. And I have all of this in the references section on this particular talk. In the meantime, too, Andy Diller has also been working on documentation, essentially a smaller getting started guide that we can ship with each FujiNet. And doing that in the style of the Getting Started Atari Disk Operating System reference manuals. Lots of pretty pictures, lots of pretty text, easy and approachable. We're really trying to do a good job here. And look, just, dear God, I just kept having to take and add slides because we're working on so much more. We have the concept of high score enabled games, and that is basically where you can play your favorite games, and if they store high scores, it will take and post them up to the network so that other people can see, so that you can have things like this, where you can play a game, you can post a score, and share that with your friends on the web. And we've done this in such a way that it works transparently, where all you have to do from the game's point of view is simply write to the disk, so to speak. And on top of that, the individual scrapers themselves are just simple C programs that listen for changes to the disk images on our servers and then take and update the pages dynamically. All of this is available, again, on GitHub. I'm going to say this over and over and over again. We have this FujiNet Wi-Fi GitHub group, and under here we have all of everything that we work on here. Everything is compulsively public, so you can take and pull it down, you can take a look at it, and if it's something that you can contribute to, we would love you to contribute to it. And we've touched on it in some of the other slides here too. The cross-platform network library in C, FNIO and FN network, which have now been merged into FNlib, so to speak. So the idea here, again, is to make cross-platform applications easier in C by producing a series of consistent verbs for all of the things that you need to do on the network: open, close, read, write, I/O control, and then things like parse JSON, etc. As well as all the Fuji control commands too. And this is important. To give you an example of why you would want the Fuji control commands, that's how the lobby works. The lobby takes and responds to user input and does Fuji control commands to mount different disks images for the different games on different servers automatically. And so what's next in that area here? Other bindings for other languages. And for that, that's a case of, well, what do you guys want? Okay, come with us and help us take and write a binding. We now have a pattern to work towards. And that, of course, again, is on GitHub. FujiNet lib. All for the different platforms. And inside each one, individual sub-libraries for Fuji control, for network control, bus abstractions, and the source for each individual method. Mark chose to do these in assembler to make them nice, fast, and compact. What else? Well, we've got this network operating system, which really, it begged the question, okay, on the Atari, you have this operating system, ROM. It can have all of these modular devices. You have the keyboard, the editor, the disk drive, the cassette. All of these have their own devices with their own handlers in the ROM, and you can load others in, such as the disk operating system or the 850 handler for the R handler, etc. Well, we added one called N for the network. And we thought, okay, well, if we have this N handler, why do we need the D handler? Well, you really don't if you're not going to use the disk drive. So we basically built this network operating system. And for those who have used something like DOS XL or Sparta DOS, it looks an awful lot like that. It's in the same place as all of the other disk operating system images for the Atari 8-bit. You just take and select it, and you boot it. And while it boots, it looks like it's booting off of the disk, but it only does that just long enough to load the handler into place. But once it's in there, you have all sorts of additional extra features that you don't have on other disk operating systems, such as an online help system, which literally takes and pulls all of its documentation directly off of GitHub. Different subsections in that help section to show, for example, the individual intrinsic commands that you have access to, because some network protocols have different features, such as being able to create directories on SMB or NFS or TNFS file servers and the like. But you also have the individual help pages, but you also have programmer documentation that's also available, that was put together. So you have a complete address map, architecture map for the Atari 8-bit systems available to you at a moment's notice. All sorts of tables And these were all things that we were able to quickly put together, post up on GitHub, and when we take and change them, those changes are immediately reflected because they're pulled off of the network in real time. Let's see, what else? But what does this mean from a functional perspective? Right now, when NOS is booted, even though NOS doesn't have anything, even though we booted from the disk, it's not attached to anything. So if we take and change the prefix of one of these network devices, say to my local TNFS file server here that I have running at home, suddenly you're able to take and do file management functions on that file server. List the directory, pull things across, and you can see that you're seeing a one-to-one relationship between what we're seeing over here on the right-hand side of the screen on the Atari versus the what's actually on my local file system here. You can load binary files directly. It just works. And here is an example, literally, of taking and dealing with something directly off of a web server. We move all the way to it using CD again, and then we immediately take and look at a piece of source code directly on that web server, and it's pulling it down transparently and directly because of the device architecture that on the Atari and what we've been able to do with the FujiNet firmware. We want to take and bring this to all the platforms. And for that, we'll definitely need your help because you guys know for your respective platforms how you want things to work. And we want to try to meet you guys in the middle in terms of integration to be able to do that. Finally, I'll end with something here. What I'm actually doing, again, recall that we CD'd directly to that web server, and now we're inside Action, inside the editor in Action, reading a copy of some Action source code because we're going to turn right back around and build it. We didn't use a disk image in the middle of all of this. That's the important part. But we took it, we built it, and again, since the end device has all these different protocols, we can take and deal with other things as well. Here's a Windows file share. Just works. So we can do things like, one of the last things I do in this video is I literally take and copy a file from the web server and bounce it over to the web server directly from one end device to another. So, moving on. So the NOS is something that shows the untapped potential of what you can do if you just let the FujiNet do everything. And again, just like before, NOS is available on GitHub. So that brings us to the last section here. What can you do? What can you do to help? All sorts of things. You can get a FujiNet to help, but you don't even have to do that because you can use FujiNet PC in a VM, and you can test these features, you can see how they work, and you can get the gears turning in your head and think, oh, I can write an application, or, oh, I can help you guys test this. I've noticed something wrong here. So you can help with writing applications, testing applications, helping us write documentation. That would absolutely be wonderful. If you have hardware knowledge for a particular system that we haven't gotten to yet, we could definitely use your help in doing the bus interfaces for other systems, for bring-ups. And you can take what we've done here and help bring it to your respective communities. Because one of the things that I've noticed with the retro computing communities in general, we all have our tribes. We all have our little corners that we all work we work in our corners. And we don't really look over the fence to see what everybody else is doing. Events like VCF really help in this regard because we all kind of come together and we have our booths and things. But it can become all the more effective when we start to think, okay, we've got this common platform where all of our platforms can now talk to each other, can communicate to each other. This creates a gravity well effect where all of a sudden the people that are off on the edges are now being pulled toward the center and looking what everybody else is doing and thinking, hey, maybe we can all come together to do something interesting. At least that's what I hope. So that really brings us to, okay, when is FujiNet coming to blank? Put your favorite platform here. Well, one of two ways. When we get hardware, either when we buy hardware or if somebody gives us a donation of hardware or a loan, or if you decide, I'm going to take and bring this platform to FujiNet, or I have a set of friends who can help, who can bring this platform to FujiNet, and you guys start to champion a particular bring-up. Because what that puts us in a position to do is to be able to help you, to bend over backwards to help you achieve that goal of being able to bring FujiNet onto your target platform. And that's why we're all floating around in this Discord that we have and why we have these GitHub repositories, because this is a very public project that we want everybody to be able to get into. I have approximately 13 minutes left, and so I'll leave the floor open for questions. And in point of fact, I mean, I should have mentioned this. Anybody could have interrupted me at any point, and I have no problem with redirecting the flow. But yeah, go ahead.
So this is like my first time really learning about the FujiNet project. Hello? Okay.
Yes.
So this is my first time really learning about the whole FujiNet project, and I'm just curious, is there any work being done on bringing FujiNet to the Amiga and the Atari ST?
Refer back to my previous slide. So the answer is yes, we want to. And because of the work that has been going on to try and get FujiNet onto generic bus devices with things like the RP2040 as a front end, being able to make a FujiNet device that can attach the Zorro bus is absolutely possible. Would you like to help in that endeavor? I figured I'd ask. I never know until I ask, and I'm not afraid to ask.
Hello? Hi.
Hi.
I apologize for missing the beginning of your presentation.
Okay.
You might have gone over this already. How much of those different functionalities that you showed are working on the Commodore 64?
The Commodore 64 at this particular point in time, no, I did not show the Commodore 64. We started on the Commodore 64 bring up last year, and it's been going at a rapid pace. We have disk is working, printing is working, the network device is also working. The issues that we're coming into with the Commodore 64 have to do with the IEC bus itself and working through all of the various edge cases for dealing with bus timings and the like. One weird example of this is the Commodore DOS wedge. With the Commodore DOS wedge, for those who don't know, is a piece of software that you can load in on your Commodore machine, which adds a whole bunch of disk management functions as basic commands, and it does this by intercepting the editor. But the DOS wedge communicates with the IEC bus sort of in a very direct manner and bypasses some aspects of the kernel. And it has been giving us an unbelievable amount of anguish trying to take and debug all of these things and to make them work. And in fact, the very person that you're sitting right next to, right here, Jamie, is the one working on the Commodore bring-up. We're grinding it through, and any help that can be given would be very much appreciated. All right. All right.
No other questions? Oh, sorry.
Oh, no, this guy.
This guy.
Yes.
But it's not about that.
For the record here, for those who can't see, he is wearing an Ohio Scientific shirt. So I know what's coming here.
Actually, no. I wanted to talk about another aspect is the cross-platform. We talked about this face-to-face. I just wanted to repeat it. Very much ESP32 is a platform, but like other dev boards, any comment on that? You talked about RP40, but
Okay, so I'll answer that in two pieces. We've added the RP2040 as a way to increase the efficiency of doing fast bus work. That works, and it works very well because the RP2040 is extremely cheap. As I mentioned before, it's, what, 50 cents in singles? And so that's a good thing, too. We have also proven with FujiNet PC that we can take the ESP32 code base that we've written and port it very easily to other microcontrollers, should the need arise. We're not married to it. This is just what has gotten us the most bang for the buck. Hopefully, okay. Well, with this dude right here.
I was looking at what you did with the color computer and the hardware, and I'm just trying to wrap my head around what effort would be needed to get that working on OS 9, since OS 9 is the same hardware but different operating system. Would it just be a software rewrite?
It would be essentially a set of drivers. Now, on the color computer, we built on top of DriveWire. And so a big portion of what's already been done for DriveWire can be used to bootstrap to add the additional functionality. In particular, the FujiNet control device and the network device can be written as an OS2 device driver. Conversely, printing already works. I tested it in OS 9. You can print to the P device, and it just spits out a PDF, which you can take and pick up. So yeah, mostly from that particular side of things, we would just basically need to work with those who know how to write OS 9 device drivers, or I will have to figure it out. It's just kind of, from my own background here, I find myself in cross-platform projects that have dozens and dozens and dozens of platforms, each with unique architectures, each with unique programming environments and tool chains. So I have no problem taking and adding another one to that list. So if I need to do it, I will get around to it, but it will happen faster if I can get some help. That's okay. Any more? We got 7 minutes. I mean, yeah. Okay, I guess that's it then. Thank you very much for listening.